Question. Discuss the implications and technical challenges of integrating zero-knowledge proofs in user authentication systems to enhance privacy without compromising security. Correct answer. A. Zero-knowledge proofs allow the verification of data without exposing the actual data, enhancing user privacy. The primary technical challenges include computational overhead and complexity of implementation, which can affect system performance and scalability. Addressing these requires optimizing cryptographic algorithms and possibly leveraging dedicated hardware acceleration. Question. Evaluate the potential privacy risks and solutions when deploying machine learning models in a multi-tenant cloud environment, considering both data at rest and in transit. Correct answer. B. Privacy risks in multi-tenant environments include unauthorized data access and inference attacks. Solutions include using homomorphic encryption for data in use, implementing robust access controls, and ensuring data is encrypted both at rest and in transit with keys managed independently by each tenant. Question. How would you architect a system to ensure compliance with the Schrems II decision on international data transfers, particularly focusing on technical safeguards that can be implemented? Correct answer. C. To comply with Schrems II, systems must ensure additional protections for data leaving the EU. This includes enhancing data encryption, using pseudonymization before transfer, and deploying technical measures like binding corporate rules, BCRs, for intra-company transfers. It's also vital to conduct regular risk assessments to validate the adequacy of these measures. Question. Analyze the feasibility and privacy implications of using biometric data for blockchain-based identity verification systems. Correct answer. D. Using biometrics in blockchain systems raises significant privacy concerns, particularly around irreversible data storage and potential misuse. Feasibility issues include ensuring the biometric data can be securely hashed without losing effectiveness for verification purposes. Privacy-preserving approaches, such as storing only cryptographic proofs of biometric verification, can mitigate some risks. Question. Discuss the technical and ethical considerations of implementing automatic content recognition (ACR) technologies in consumer devices from a privacy engineering perspective. Correct answer. A. ACR technologies, which identify content played on a device to provide targeted advertisements, pose privacy risks related to unauthorized surveillance and data profiling. Technically, ensuring that data collection is minimized and anonymized is crucial. Ethically, transparency and consent are paramount, alongside mechanisms for users to control or opt out of data collection. Question. How can privacy engineering principles be applied to the development of smart city infrastructure to both enhance urban management and protect individual privacy? Correct answer. B. Smart city projects should integrate privacy by design, collecting only necessary data with high levels of anonymization and encryption. Technical implementations should include secure multi-party computation for data processing and decentralized data architectures to limit centralized points of vulnerability. Question. Evaluate the impact of quantum computing on current encryption standards used in privacy engineering and propose mitigation strategies to preemptively address these challenges. Correct answer. C. Quantum computing threatens to break many current encryption methods. Mitigation strategies include transitioning to quantum-resistant cryptographic algorithms, such as lattice-based and hash-based cryptography, and updating existing systems to support these new standards to ensure long-term data protection. Question. What are the unique challenges of ensuring privacy in augmented reality (AR) applications, and how can these be addressed through innovative engineering solutions? Correct answer. D. AR applications can intrusively collect and overlay personal information on real-world environments, raising significant privacy issues. Solutions include using dynamic consent interfaces that are context-aware, deploying minimal data capture technologies that process data locally, and developing privacy-preserving AR frameworks that restrict data access based on user settings. Question. Discuss the technical mechanisms and policy measures necessary to implement a privacy-aware public health surveillance system in the wake of a pandemic. Correct answer. A. Such systems should use data minimization, anonymization techniques, and decentralized data processing to protect individual privacy. Policy measures must ensure transparency about data use and storage, enforce strict data access controls, and provide clear guidelines for the destruction of data post-crisis. Question. How can the principles of federated learning be applied to develop privacy-preserving AI models in healthcare, considering both patient confidentiality and the need for predictive accuracy? Correct answer: B. Federated learning allows AI models to be trained across multiple decentralized devices or servers holding local data samples without exchanging them, which preserves privacy. Ensuring patient confidentiality involves using secure multi-party computation and differential privacy during the model training phase to prevent data leakage while maintaining the necessary predictive accuracy for effective healthcare outcomes. Question: Describe how you would design a data system to comply with both the principles of privacy by design and the GDPR's requirements for data minimization. Include specific technical strategies you would employ. Correct answer: A. To comply with privacy by design and data minimization, I would implement strict access controls, use data pseudonymization and encryption techniques, and design databases with segmentation to ensure only necessary data is processed and stored. Additionally, I would incorporate automated data lifecycle management to ensure data is deleted when no longer necessary. Question: Analyze the challenges of implementing differential privacy in real-world applications. How would you address the trade-offs between privacy protection and data utility? Correct answer: B. Differential privacy introduces randomness to queries on statistical databases, which protects individuals' privacy but can reduce the accuracy of the data. To address this, I would fine-tune the privacy budget and develop optimization algorithms that maximize data utility while ensuring robust privacy guarantees. Collaborating with data scientists to understand the minimal data needs for meaningful insights is crucial. Question: Discuss the integration of homomorphic encryption into existing data processing workflows. What are the potential performance impacts, and how can they be mitigated? Correct answer: C. Homomorphic encryption allows computations on encrypted data, offering strong privacy guarantees but at the cost of significant computational overhead. To mitigate performance impacts, I would evaluate the feasibility of partial homomorphic encryption schemes that are less computationally intensive and optimize cloud infrastructure to leverage high-performance computing resources. Question: Given the rise of IoT devices in consumer markets, outline a framework for ensuring these devices comply with stringent privacy regulations like the GDPR or CCPA. Correct answer: D. The framework would start with ensuring all IoT devices collect only essential data, employ data anonymization techniques at the point of collection, and securely transmit data using end-to-end encryption. It would also include robust authentication mechanisms, automatic security updates, and a transparent privacy policy that informs users about data usage and their rights. Question: Explain how you would use privacy-enhancing technologies, PETs, to develop a health application that needs to be compliant with HIPAA regulations. Correct answer: A. For a HIPAA-compliant health application, I would implement PETs such as Secure Multi-Party Computation, SMPC, to enable data analysis without exposing individual records. Additionally, data access controls would be enforced through attribute-based encryption, ensuring that only authorized parties can access or process sensitive health information. Question: Evaluate the effectiveness of synthetic data generation in protecting privacy. What are the limitations, and how can they impact compliance with privacy laws? Correct answer: B. Synthetic data can effectively mask personal identifiers, thus protecting privacy and allowing broader data use. However, limitations include the potential for residual information from the original datasets to persist, which could lead to privacy breaches if not properly managed. Ensuring compliance involves rigorous testing to detect and mitigate any indirect identifiers or patterns that could lead back to real individuals. Question: Discuss the role of blockchain technology in privacy engineering, particularly in terms of user data control and transparency. Correct answer: C. Blockchain can enhance privacy by decentralizing data control, allowing users to manage their information without relying on a central authority. It provides transparency through an immutable record of data transactions. However, privacy engineering must address challenges such as the permanent nature of blockchain records and the potential exposure of metadata. Question: How would you ensure that an AI-based system respects user privacy when utilizing large datasets for machine learning models? Correct answer: D. To ensure privacy in AI systems, I would implement federated learning where possible, allowing models to be trained locally on users' devices, significantly reducing data exposure. For data centralization, I would use techniques like data anonymization and differential privacy to ensure that individual data points cannot be traced back to users while maintaining the utility of the data for training purposes. Question: what are the key considerations when implementing privacy-aware user authentication systems? Correct answer: A. Key considerations include ensuring that authentication data, such as biometrics, is stored in a secure, encrypted format, using least privilege access principles, and implementing strong user data protection mechanisms to prevent unauthorized access. Additionally, privacy-aware systems should allow users to control what personal data is shared and understand how it is used in the authentication process. Question: critically analyze the use of edge computing in privacy-sensitive applications. What are the benefits and potential risks associated with processing data at the edge? Correct answer: B. Edge computing can enhance privacy by processing data locally on the device, reducing the risk of exposure during transmission to centralized servers. However, it introduces risks related to securing multiple edge devices and ensuring consistent application of privacy policies across